This is from Thursday 1/7. All right, this is called evaluating polynomial functions. We've done this before. These are just bigger functions, okay? A couple things we want to remember about it. This is from first semester, but these are bigger polynomials now. We only did quadratics, I think, first semester. So we're given a function. It's a polynomial function. Our exponents are nice positive integers, okay? These are all going to be polynomial functions. Otherwise, the question's silly because it's saying evaluate the polynomial, so it's implied it is a polynomial. And all it's saying is to figure out what the function's equal to when x is 3. So this is what your work should look like. Every place you see an x, you replace it with a 3. And when you replace the x with a 3, you always stick it in parentheses. Just the x part. Don't put the 2 here in parentheses, but you will put parenthesis, replace the x with 3, close your parenthesis, then the squared. Then minus 5, parenthesis, put your 3 in there, close your parenthesis, and then plus 6. When you work on a function like this, this is called, this means the same thing as just y equals. Okay, but this function notation allows us some more versatility. Okay, and you never ever do anything other than that little substitution to the left-hand side. That is saying, what is the value of this function, this thing right here, when the x is changed to a 3? So that's the question on the left-hand side. On the right-hand side, that's where you do all your work. So you just go equals, and you just kind of continue the right-hand side work. We follow order of operations. Remember PEMDAS. Okay, we look to see if we can do anything in the parentheses, but in the parentheses we just have a number, so we can't do anything. There's no subtraction to do in there or anything like that. So we've taken care of inside the parentheses. Then we take care of exponents. So let's do our exponents. So we got 3 cubed. 3 times 3 times 3 is 27. And then we got 3 squared. So that's 3 times 3, which is 9. Okay, so I've taken care of all my exponents. Done parentheses, exponents. Now I got to do any multiplications. So I got 27, 2 times 9 is 18, negative 5 times 3, negative 15. No divisions in the thing. So now I can do additions and subtractions, just working left to right. So let's see here, 15, carry 1, 2, 3, that's 45. That's 30, 45 minus 15, and that's 36. And every time when you work your problem correctly, you're going to get this inverted triangle look. And so when we get done, what we would say is we'd say, well, the f of 3, so the function when x is 3 is equal to 36. That's our answer. This is all of our work to get there. Okay, you definitely, even if you use a calculator, you need to show that setup. And if you do use a calculator, you want to enter parentheses just like you've done, and you'll get the correct answer every single time. Your calculator does know order of operations, so it will follow along and do it just great. So another example here. H of x, this time we want our x to be negative 1. H is just the name of this stuff. The x is saying what variable is in it. Okay, if I had to use the variable w, it'd be the h of w. If I use the variable k, it'd be the h of k, and I'd have k's in my equation. So again, we just rewrite this function, but every time we see the x, we replace it with negative 1. So I've got, let's use blue for this closed off parentheses, negative 2, parenthesis, here comes that negative 1, close my paren, 5 to the 5th power, minus 3, parenthesis, here comes a negative 1 to replace that x, squared plus 7. All right, let's take care of exponents first. Negative 1 times negative 1 times negative 1 times negative 1 times negative 1, that, I believe, is going to give me a negative 1. It's an odd number of negatives multiplied together, so you get a negative. Here I got an even number. I'm squaring. Negative 1 times negative 1 is positive 1. So I've taken care of my exponents. I do some multiplication. Negative 2 times negative 1, positive 2. Negative 3 times 1, negative 3. subtract and add left to right, negative 1 plus 7, and finally 6. Again, a nice inverted triangle, simplified down to the smallest answer. The h of negative 1 is clearly equal to 6. And then this is what your assignment looks like. Okay, so here's your function. They tell you what to plug in for x. So this first problem, you would start with h of negative 2 equals negative 3 times negative 2 to the 4th plus 2 times negative 2 cubed minus 12 times negative 2, running out of room, minus 6. That's really messy, but that's how you start it. And then again, you just work on this right-hand side till you get down to your final answer. Should take care of that section from Monday.